Good afternoon, and welcome back to a video series on MAT 1033 Intermediate Algebra. My name is Sean Perry. This is video 11, Graphs and Graphing Equations. When we say that we want to graph something in algebra, what we really mean is we are trying to draw a picture of it. One common way to depict numbers and groups of numbers is to plot them on a number line. Since the numbers have an order to them, one follows another, we consider the line to be a good way of illustrating where numbers are in relation to each other. Let's refresh ourselves with an example for just groups of single numbers and how we might plot them on a number line. A number line is usually drawn like this. We have a line, goes on forever in each direction, and we make some tick marks to show where some of the big landmarks are, the whole numbers, the integers in this case. And then we take the collection of numbers that we want to depict, that we want to graph, and we put a point to represent them on the number line. So here I've got one for 3, I've got one for -2, I've got one for 0, and even though that doesn't have a tick mark, I put a point right here for the number between 0 and 1 to represent 1/2. And shading these points in a different color or making sure that they're clear and distinct from the number line underneath it is really what we mean by to graph a point on the number line. We just want there to be some graphical depiction of that point that we can see. Now, a big focus in this course is going to be plotting pairs of numbers that will, in some sense, let us visualize an equation and give some picture that represents it. Usually to do this, we solve the equation for one of the variables involved and treat that as an output. And some other number, which will be inside the equation, will be our input. This output number is usually called the dependent variable and is denoted with a y. The input number is called the independent variable and is usually denoted with an x. Here's an example where we have already solved for the output variable y. We have y equals 3x plus 2. Now, we don't know yet what x and y are. They're variables, which remember means kind of like a blank space. It's open to receive a number. I could put in a number for x, and if I did, I would multiply that number by 3 and add 2 to it, and that would give me the output number, y. So you should think of an equation kind of like a rule that takes in some input, does some things to it by a certain rule, and then gives you a number back. But now let's think about some particular values for y, when we're given particular values for x. The way that we usually depict that is with a table. I can pick some values for x and plug them in my rule equation where I saw an x. So here I've replaced x with 2. 3 times 2 is 6, plus 2 is 8. And so the y value I get back if I plug in x is 2 is an 8. Likewise, plugging in 0, I get 2, and plugging in -1, 3 times -1 is -3, plus 2 is -1. So we have these pairs of points. We call them coordinate pairs. And they're sort of linked with each other. 2 should be thought of as linked with this 8. The way we're going to graph equations is by marking those pairs of points on 2 number lines. There'll be a horizontal number line for the x values and a vertical one for the y values. Before we do that, let's just mark a single point. Here I've marked the point 3, 2 on the number plane. The 2 number lines together make up a whole plane's worth of numbers. Worth of coordinates, and we are going to mark 3, 2. So 3 corresponds to this x value of 3. We always mark them x comma y. We usually orient the x-axis going to the right, the y-axis going up. That's the standard orientation. The 2 number lines intersect each other at 0, 0. That's this point right in the middle called the origin. And so this point 3, 2, again, is right above the x value of 3 and over from the y value of 2. So you consider this to be the value of y, it's 2, and these to be the value of x, being 3. And where are they both? Where is the x3 and the y2? It's right here at this point that I've marked. So now let's graph some more points. Let's use our first example. This will be a critical example, so I want you to copy this for your notes. So I've written down the old equation, y equals 3x plus 2. You don't need to color code this for your notes. I just thought it would be helpful. I've plotted the points that we had before, 2, 8, 0, 2, and -1, -1. That's here. But I've also plotted a couple more. Here's 1, 5. Plugging in 1, I get 5. So x is 1. That's here. Y is 5. There's my point. And then minus 2, if I plug in minus 2, I get minus 6 here. Plus 2 is minus 4. That's here. Minus 2 for x, minus 4 for y. And then we connect the dots, right? I could have plugged in negative 3/2 or positive 1/4 or any other of the numbers on the x-axis could have been plugged in, and you'd get more points. But instead of plotting all of those, listing all of them in a table, what we do is we sort of connect the dots. We fill in the gaps to show the pattern in its entirety of what would happen if you plugged in numbers off the x-axis and then plotted their y values correspondingly. You would fill in the gaps and you would get this entire green line that I've drawn. So this green line represents the equation y equals 3x plus 2. Now let's talk about a new function. Maybe you've seen it before, but we'll introduce it here. This is the function called the absolute value. It's an equation that we're going to be using quite a bit. And what the absolute value does is it tells you what the distance from 0 of the number inside is. Distance is always a positive thing. And for positive numbers, that is the number itself. We would say that 2, the number, is 2 units in distance from 0. And 1/2 is just a half of a unit away from 0. Where we have to change something is if it is a negative number. The distance of negative 2 from 0 is positive 2. And the distance of negative 1/2 is positive 1/2. And so don't let this be any more complicated than it has to be. If you plug in a positive number into absval, it really doesn't do anything. It just gives you that number back. And likewise, if you plug in a negative number, it just gives you the positive version of that number back. So we sometimes say for absolute value, if it's positive, keep it positive. If it's negative, make it positive. We'll be looking at absolute value enough that I want you to copy this for your critical notes. So here are some points. Here are their absolute values. And here is the plot of those points and the line connecting them. I want you to notice it is not just a line. It's actually kind of this combination of two lines. But we would still say this is not linear. It's not a line. All right, now let's look at the praxis for this video. These are your praxis exercises. Please fill out each of the following tables and try to graph what you see. So these are the example problems. Pause the video at this time and give this a shot. Okay, let's see how you did. So here I have not yet solved for one of the variables. I have a mixture of x's and y's on this side. Well, no matter, we could actually just get rid of the x's on each side. The x term is 2x. Let's move it on over here and solve for y in this way. When we do that, we wind up with y equals minus 2x plus 3. And this will give us an output of y for an input of x. We've solved for y in terms of x. So let's look at this point minus 2. If I plug in minus 2 here, I get minus 2 times minus 2, that's positive 4, plus 3 is 7. So that would be this point here, minus 2, 7. And let's fill in our table with minus 2, 7. Likewise, if I plug in 0, I get 3, and that corresponds to this point here. If I plug in 2, 2 times minus 2 is minus 4, plus 3 is minus 1, so I get a minus 1 here. So at 2, get minus 1, that's here. And now let's figure out what value of x would give me a 1 for y. Well, we haven't solved for x. We could rearrange this and solve for x, but instead, let's just plug in the 1 where we see a y and solve for x with the numbers in place. So I'll minus 3 from both sides to get minus 2, and divide by the minus 2 coefficient of x to get 1. So we will get, for a y value of 1, an x value of 1. And that's this point here. Likewise, if I want to know when do I get 5 for y, I plug in 5 for y and solve for x. And that gets me a minus 1 for my x value. That's this point here. We connect the dots, and this is our line. This line represents the function y equals 2x plus 3. Now let's take a look at the absolute value. the absolute value has a +1 inside. How is that going to affect things? Well, we need to just plug in the -2 for our x, and we'll get a number back. So -2 plus 1, that's -1. And then we take the absolute value of it. We do the inside part of the absolute value first, like it was a parentheses, and then we evaluate it. And that -1 that we would get inside, -2 plus 1 is -1, absolute value of -1 is 1. And so on and so forth. Plugging in -1, we would get 0, absolute value of 0 is 0. Plugging in 0, we would get 1, absolute value of 1 is 1. Plugging in 1, we get 2. Plugging in 2, we get 3. Now let's plot those points and connect the dots. I want you to notice that those points moved the v over a little bit. It no longer had its point at the origin. Now it seems to have shifted to the left by -1. Well, that's our graph. That does show this equation here. That shows all of the points now, even the kind of in-between points that we didn't plug in, are shaded on this graph to show what values would make this equation here true. And we note that it seems to have shifted things over. We will look at that in a lot more detail later on in this course. Okay, thank you for your patience and have a great day. That concludes this video. Good luck with your studies.